Setting up a cascade mode allows us to control how the Fluent validation library treats validation failures. There are two cascade options: continue and stop. There also are two levels at which you can set up this option: inside an individual rule chain and between rule chains. By default, Fluent validation uses the continue option, which means that all rules in all rule chains in the validation class will be executed regardless of whether any of those rules fails. We can override this behavior. If we set the cascade mode in a rule chain to stop, then the validation will proceed until it finds the first failure and will stop after that. Note that the library will still invoke the remaining rule chains. This setting only affects rules in the specific rule chain. To stop the validation altogether, including the remaining rule chains in the validation class, we can configure the cascade behavior at the class level. This will affect the continuation of both rules in individual rule chains and between rule chains. Finally, you can also set up the cascade mode globally. This is equivalent to setting the cascade mode at the class level in all existing validators. Let's now look at how we can better integrate the Fluent validation library with ASP.NET. Right now, there is an issue that we have to call the validator manually, and we have to do that in all of our controller methods. Not only that, this method of validation is not idiomatic from an ASP.NET perspective. There already is a way to do validation in ASP.NET, and that is using this model state property. If the model state says that our model, which is the register request, is invalid, then we can extract those errors from the state and return them to the client. It's best to adhere to the idiomatic approach to validation and not reinvent the wheel, which we essentially did here. Right now, if we try out this code, it wouldn't work. Let me actually show you that. If I put a breakpoint here, run the application and set an incorrect phone number, you can see that the model state says that our request is valid, which is not true. Luckily, Fluent validation allows us to integrate into the ASP.NET pipeline such that we can use the standard model state property. For that, we need to install another NuGet package. But before we do that, I need to update our Fluent validation library. I've already upgraded it from version 9 to a preview version 10 behind the scenes, and now I need to install a more recent preview version. Don't worry about compatibility. All the functionality we discussed in the course works the same as in version 9. And now we can install the NuGet package that allows us to integrate Fluent validation with ASP.NET Core. The integration itself can be set up in the startup class. We just need to call this extension method after adding our controllers. This method integrates the Fluent validation library into the ASP.NET pipeline such that all errors generated by the library will show up in the model state. We also need to register our validators. We can do that explicitly using this method, but it's easier to ask Fluent validation to register them all automatically. For that, we need to call this method. It will use reflection to find and register all validators in our assembly. And I don't need this line anymore. The way it works is it looks at the type of the incoming data contract and then searches for the validator that works with that type. It then invokes this code here automatically and puts all the errors in the model state property. Let's move this breakpoint a little bit higher and run the application, sending the same request. And you can see that now the model state does report an error. And if I hit F5, Postman shows our error message. Very good. We can also extract the errors from the model state to show them to the client. For that, I'm searching for the first value that has errors in it, then take the first error and extract its error message. I'm then returning that message back to the client. Let's run our application again. And you can see that our API correctly indicates the error with our request. The phone number is incorrect. We can also display not just the first error, but all errors found by Fluent Validation this way. For that, we need to first remove the cascade mode that we set up earlier in this module, so that Fluent Validation doesn't stop when it sees the first error. And we can also bring back this code while we're at it. We don't need the must method anymore, and deleting these comments too. Very good. Now we can gather all values with errors, select the first errors message from each of those values, combine them into an array that I'm renaming to errors, and then show them all by joining into a single string. Let's try this out. Sending the same request. Good, the API shows the single error. And if we modify the email and try to submit this request, you can see that the API now shows both error messages here. And if I also replace the name with a null, the third error shows up as well. Let me change everything back. Okay, there is one important thing about how validators are resolved in ASP.NET. The default dependency injection container in ASP.NET only resolves one validator per data contract. It means that we cannot create a second validator for the same register request. Well, we can, but ASP.NET will only register one of them. Let me show you that. I've created a second validator for the same request, and in theory, that second validator should also contribute errors into the model state. But if we put an invalid phone number here and look into the errors in the model state, you can see that there is still only one error here. This is a shortcoming of the built-in ASP.NET dependency injection container. When you try to register two services for the same interface, which Fluent Validation essentially does here, ASP.NET overrides the first registration with the second one, and therefore, when Fluent Validation tries to validate the request, it only finds one of the validators. You cannot register multiple services for the same interface with the built-in ASP.NET dependency injection container. Here you can see I'm trying to inject the validator in the controller, and when I run the application, this validator resolves to the second class. The first one gets overridden. And if I try to do something like this, I will get an error from ASP.NET. This is not a big deal because it's generally not a good practice to create multiple validators for the same data contract. Just something that you need to keep in mind when integrating Fluent Validation with ASP.NET. Let me remove the second validator from here. Good. So far, we've integrated the Fluent Validation library checks with the ASP.NET pipeline, such that all the validation results are populated in the standard model state property. We can still improve this implementation though. We can configure our application in such a way that there is no need to manually check this property at all. How can we do that? We can mark our controller with a special attribute called API controller. This attribute tells ASP.NET that we only use our controller as an API. ASP.NET enables some additional features for such controllers, one of which is automatic validation. Essentially, what ASP.NET does is it checks the isValid property automatically before the start of each controller method, and if there are any errors, it returns a 400 response with those errors. We can also change the base class for our student controller to controller base instead of just controller. Controller base is a trimmed down version of the controller class and only contains method needed for the API. Let's put a breakpoint here and run the application. Sending the request. And you can see that the API has returned a validation error response. This response has a standard format ASP.NET uses by default, and here is our validation error. It correctly states the field with the error and the error message. Notice that our breakpoint was not activated. It means that ASP.NET didn't even invoke this controller method and did the validation automatically beforehand. Let me comment this out. We will not need this code anymore. Another thing that the API controller attribute does is it automatically infers the binding source for the incoming data. If we specify a complex type as an argument to a method of such a controller, ASP.NET will automatically try to deserialize it from the body of the request. And so we don't need this attribute either. Let me delete it from here and here too. Finally, the last thing we can do is we can introduce a base class for all controllers in our application. I'm calling it Application Controller. This is useful because we can gather all common controller functionality in this class and then just inherit our controllers from it. One piece of such functionality is this API controller attribute. It will affect all inherited controllers. Changing the base class and removing the attribute. Good.